Hi guys, welcome to Video Notes G. I'm going to teach you how to solve some different types of equations that also contain sine. Now, the equations you see today are just going to be slightly different than the ones from yesterday, but it's the same premise. We want to know what angles would satisfy the equation. It's the same kind of thing as if I gave you this equation to solve. The only way to go about this one, 2x squared minus 4x equals 0, is to factor out a GCF. The GCF here is 2x. When you take that out, you're left with x minus 2. At this point, you set each of those factors equal to 0, 2x equals 0 and x minus 2 equals 0, and you would come up with two answers, 0 and positive 2. It's the same thing in a trig equation like this one. The only thing we can do here is factor out a GCF. The greatest common factor between 2 sine squared theta and sine theta is just a sine theta. If we take a sine theta out of each one, we're left with 2 sine theta minus 1. At this point, we set both factors equal to 0. Sine theta equals 0 and 2 sine theta minus 1 equals 0. We can solve both of these. Sine theta equals 0. That one's easy. Zeros, ones, and negative ones come from the sine curve. What angle has a sine of 0? Well, 0 does, 180 does, and 360 does as well. Let's do this other one. If we add 1 to both sides, we see that 2 sine theta equals 1. So sine theta equals 1/2. That's a positive 1/2. I know of two places where sine is positive, quadrant 1 and quadrant 2. Now, what's my reference angle? Well, the angle that has a sine of 1/2, that's 30. In quadrant 1, that's just 0 plus 30. In quadrant 2, that's 180 minus 30. So my two answers from this portion are 30 and 150. Now be very, very careful. The directions say that we want angles that live between 0 and 360. 0, though, doesn't count. 360, however, does. So for our equation that we just solved, 0 technically isn't a solution. Our four answers here are just 180, 360, 30, and 150. Pause the video and try the example below. This next type is quadratic. You solve these quadratic trig equations in the same manner you would solve this quadratic equation. Now here's the problem. Try as you might, this quadratic doesn't factor. So we have a different way. That's right, the quadratic formula. If you forgot it, it goes like this. X equals negative b over 2a plus or minus the square root of b squared minus 4ac, and that is over 2a. For this one, our a, b, and c would be 1, negative 3, and 1. So the quadratic formula would look like this. X equals 3 over 2 times 1, which is 2, plus or minus the square root of b squared, that's 9, minus 4 times a, which is 1, times c, which is 1, over 2 times 1, which is 2. That means that x is just 3/2, plus or minus 9 minus 4, it's 5, over 2. Now with regular quadratics, I ask you to leave your answer like this. It's an exact value. For trig equations, though, it's just going to be slightly different because we're not solving for x in trig equations. We're solving for the sine of x or the sine of theta, and then ultimately solving for that x or theta. So here we go. We're about to solve this quadratic trig equation by the quadratic formula. Before we attempt that, let's move 9 to the other side. That gives us 6 sine squared theta plus 7 sine theta minus 9 equals 0. Now this quadratic you can try really hard, but it won't factor. So let's go ahead and pick off our a, b, and c before we try to substitute into the quadratic formula. A, the number multiplied by sine squared here is 6. B, the number multiplied by sine theta is 7. And C, the number by itself is negative 9. Now our quadratic formula. This time it shouldn't start with x equals. Here, the variable is sine theta, so sine theta equals. Remember how yesterday we solved for sine theta, then we figured out theta? It's going to be the same process today. So let's go ahead and substitute into this quadratic formula. Negative b would be negative 7 over 2 times a, which is 6, that's 12, plus or minus the square root of b squared, that's 49, minus 4 times a, which is 6, times c, which is negative 9, over 2a, again, 12. At this point, you could simplify what's under this radical, but a value that looks like this isn't going to help us with respect to sine. We don't really even know at first glance if this number right here is negative or positive, and even if it's over 1 or less than negative 1. So here's what I want you to do. I want us to approximate each of these answers. Sine theta equals negative 7/12 plus rad 49 minus 4 times 6 times negative 9 over 12, and negative 7/12 minus the square root of 49 minus 4 times 6 times negative 9 over 12. To do this, you're going to need your calculator. So we can go ahead here and we can calculate. We need a fraction, so control fraction. Negative 7 over 12 plus another fraction, the square root of 49 minus 4 times 6 times negative 9, and that is over 12. This first value is approximately 0.773235. This value should jump out at you as a very plausible sign. Some angle can have that as its sign. Let's try the other one, the minus version. All you have to do is go up and get that exact same thing you typed, but then backspace to the plus, and just make it a minus. This one, negative 1.9399. This one should jump out at you as not being a possible sign. This number that's less than negative 1 cannot be the sign of an angle. Therefore, our answers are going to come strictly from this sign value. Now, just like yesterday, this is a positive sign value. Thus, our two answers are going to live in quadrants 1 and quadrants 2. I don't know if you memorized what angle has this sign, but I know I didn't. The way we figure that out is to take the inverse sign in our calculator. We can take the inverse sign then of that positive value and realize that 50.6453 is the angle that has that sign, at least in quadrant 1. The directions say round to the nearest tenth of a degree. This answer, rounded to the nearest tenth of a degree, is 50.6 degrees. So 50.6 is our reference angle. In quadrant 1, that's just 50.6. In quadrant 2, that's 180 minus 50.6, or 129.4. Two solutions to this quadratic trig equation, 50.6 degrees and 129.4 degrees. Pause the video and try the one below.